Welcome to Kojo's Pre-Algebra. Today we're talking about graphing linear inequalities. One thing I want to remind you of is, remember when we had x is greater than 3, or we were solving inequalities with a single variable? Remember on the number line that when it was greater than or equal to or less than or equal to, the dot was solid to show that it was equal to as well. When it was just x is greater than 7 or x is less than -4, the dot was open because it wasn't equal to that number. It was equal all the way up to, but not including that number. I want you to keep that in mind as we're going and talking about graphing linear inequalities, which means that we're going to be graphing with x and y, the ordered pair. And what it means is that we take any ordered pair and we plug it into a linear inequality, which means both variables are to what power? To the first power. They're to the first power. If x is to the first power and y is the first power, you're dealing with a linear inequality. So what we do is, if I give you an inequality y is greater than x plus 2, and then I give you the ordered pair 2, 5, and I have a question mark, is it a solution? You plug it in to the values of x and y and you replace it. That will be on the test this week. So if I plug in a 5 for y and a 2 for the x, I get 5 is greater than 4. Well, that's true. Alright, so how do you show that on a graph? Because notice that I can't plug in and solve for this one where it can be equal. My points have to be where y is greater than x plus 2. I want you to think about that for a second as we go on, because it says, how do you show that solution on a coordinate plane? Because you can't use a number line because you got x and y, the ordered pair. Alright, so the first thing you're going to do is you're going to write the inequality in the form of y equals mx plus b. Now you're not going to use the equal sign, but you're going to treat it the same way, where if you isolate the y and have a positive 1 as the coefficient of y, you will have the slope and the y-intercept of the inequality. The thing you have to remember is, don't replace the inequality with the equal sign, because it's an inequality. But you can use the form of y equals mx plus b to isolate the y. Then what you're going to do is you're going to identify the slope and the y-intercept so that you can graph the inequality. And then it says, what does it look like? Well, go back to what I talked to you about when we had a single variable, x on the number line, with greater than or equal to or just less than. It was, if it had greater than or equal to or less than or equal to, it was a closed dot to show that it was included. If it was just greater than or it was just less than, then it was an open dot. So when we have a linear inequality, think about when we graph an equation, just a regular equation like x plus y equals 3. Regular equation, x plus y equals 3. When we graph that equation, we draw a line, a solid line, because all the solutions to that equation are on that line. Well, an inequality is different. Which one do you think is a solid and which one do you think is a dashed line? And then how do you show the solutions? Because they may not, if it's just less than, if it's x plus y is less than 4, then you can't graph the line, because the solutions aren't on the line. They're either above it or below it. Well, I know I'm probably confusing you, so let's move on. So here we go. I want you to look at this. Draw a little axis, it doesn't matter. And then write this down, 3x minus 2y is greater than 6. I'm starting out with the most difficult inequality first. I get my pen. You notice my Mr. Owl is in the jungle today. He's got my favorite thing, howdy folks, because it's my favorite expression from down south. Alright, so I'm going to put this in slope-intercept form, but I'm going to keep my inequality. Now notice when I do this, I'm going to subtract 3x from both sides, so I get negative 2y is greater than negative 3x plus 6. But I've got to divide everything by negative 2. Don't forget, everything we've learned, we have to expect to be able to, I expect you to be able to use. When I divide an inequality by negative 2, what happens to the sign? Remember? It flips. So I divide everything by negative 2, and the inequality goes from greater than to less than. Very important. So when I divide everything, I get negative 2, divide everything, I get y is less than, the negatives cancels, 3/2 x minus 3, because positive 6 is divided by negative 2. Don't forget to flip that sign. Now I'm going to graph this. I'm going to go to negative 3 as my y-intercept, and I'm going to plot that point. And then I'm going to say my slope is rise over run, just like I do for any line. A rise 3 and run 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Now, I can't draw a line. I can't make it a solid line because it's an inequality. And it doesn't say that it's less than or equal to, it says that it's less than. So any point that lies on this inequality, any coordinate point, does not make it true. Because if it was on this inequality's graph of a line, then it would say less than or equal to. But it says less than. So whenever we have less than or just greater than, then it becomes a dashed line, because not one point on this satisfies this inequality. For instance, let's pick the point when x is 0 and y is negative 3, because that's the y-intercept. Plug it in. When x is 0, y is negative 3. So this is 0, right? 3 times 0 minus negative 2 times negative 3 is positive 6. Is positive 6 greater than 6? No, it's not. It's not greater than 6. It's equal to 6. So it's on this graph of this inequality, but it's not a solution. So therefore the line must be dashed. Well, where are the solutions? They're either above or below the line, this dashed line. And it can be any of these coordinate points, because not one of them on it. Well, how do you know which one it is? Which side to shade? Well, what I like to do is go to the point 0, 0. Because this point 0, 0 is above the graph of this inequality. So let's plug it in. When x is 0 and y is 0. This is 0 minus 0, which is 0. And is 0 greater than 6? No. 0 is not greater than 6. So where must we shade the graph? Below the graph of the line. So this is my solution. This is how I show it. I shade below the dashed line. And that means that any coordinate point that goes all the way up to, but not including the line, is the solution. I have to write 3x minus 2y is greater than 6. So 0, 0 will not make this true. Let's look at this one. This one should make it true. And this is when y is 0, x is 3. If y is 0, x is 3. Well, let's plug that in. X is 3 and 0. Because we're saying that it makes it true. Alright, so 3 times 3 is 9. Minus 0. Because 0 times negative 2 is 0. So 9 minus 0 is greater than 6. Yes. So that makes it true. So that means anything below this is a solution. Alright. It's a little confusing, isn't it? But notice how I label my inequality. Alright, let's look at this one. Alright, so I already put this in slope-intercept form. And I'm going to go and I'm going to plug in a 1 for the y-intercept. And I'm going to graph my slope, which is rise, drop 1, run 2. Drop, run 2. Now this one's different. It's greater than or equal to. So that means anything on this line, if I graph this as a line, a linear equation as opposed to a linear inequality, it would be y equals negative 1/2 x plus 1. Y equals negative 1/2 x plus 1. That means it makes it, anything on the line makes it true. So I have to draw not a dashed line, but a solid line. A solid line. Now, that is going to show me that anything on this line will be a solution to that inequality. Okay? So let's check it. If we know that the y-intercept is 0, 1, if x is 0, y is 1. So 1 is greater than or equal to 0 plus 1 is 1. So 1 is greater than or equal to 1. That's true, it's equal to it. But now we're not done. Because of the inequality, we have to shade. Whenever you have a linear inequality, you have to show shading to show where all the other points are that would make that true. So again, I'm going to go to my trusty point, the point 0, 0, which is right here, and I'm going to see if the point 0, 0 will make this true. Well, negative 1/2 times 0 is 0, and 0 plus 1 is 1. And y is 0. Well, is 0 greater than or equal to 1? No. So the shading isn't down here because that doesn't make it a true inequality. The shading is above, and everything above makes it a true inequality. So I have to label it y is greater than or equal to negative 1/2 x plus 1. Alright. I want you to try these two. Pause the video. This one's going to be hard. Hint, hint. You should see immediately it's minus 4y, so you're going to be dividing by negative 4, so what's going to happen to that sign? Pause the video, write these in slope-intercept form, and then graph them. Just a quick sketch is fine. Remember, this is probably going to be you should know already, this one is a what kind of line? And this one is what kind of line? Okay, pause the video, do the work, and we'll check it out. Alright, let's see how you did. If you notice, I'm going to divide everything by negative 4, the sign flips. It becomes y is less than or equal to x minus 2. It's a solid line because it's less than or equal to. I labeled it, and when I plugged in the point 0, 0 here, 0 is not less than negative 2. So it can't be above the line, the solutions have to be below. Y is less than 2x. Well, what's my y-intercept? 0. Remember, if it's not there, it's 0. That one's tricky, but you should know it's not a solid line, it's a dashed line, because it's less than. So dashed line, now I have to determine where it is. This is a little bit trickier because my point 0, 0 is where my graph goes through, my inequality. So I'm going to say, well, what do I want to use? I'm going to use the point when x is 0, y is 3. X is 0, y is 3. So y is 3. When x is 0, y is 3. And see, I got it from picking a point from up here above the line. So 2 times 0 is 0, and 3 is less than 0. That's just not true. So it has to fall, all the points are below. So all the solutions to this inequality lie below the line. And it's a dashed line, but that means my solutions go all the way up to it, and it's y is less than 2x. Well, that's it. I hope you did well. I want you to I will be back tomorrow in class, so bring 2 things that you learned about inequalities and 1 question that you still have. I hope you have a great night. I'll see you soon. Bye-bye.